Hello, my name is Kuldeep Jajoria. Our work is detection of ultrasound up to 10 MHz using a fiber grating sensor. This work is performed in Muse Lab at IIT Gandhinagar. Ultrasound metrology is necessary for the safe and effective use of biomedical ultrasound. Hydrophones are typically used to measure acoustic pressure. Despite wide bandwidth and omnidirectional, conventional hydrophones are susceptible to electromagnetic interference. Along with, they are fragile and expensive. FBGs are an alternative approach to detect ultrasound. FBGs are immune to electromagnetic interference and provide high sensitivity. Along with these properties, they have multiplexing capabilities as well. In the previous studies, authors have reported the detection of FBG up to 3 MHz. A detailed characterization of FBG response up to 10 MHz has been present in this work. FBGs is a small segment of fiber in which a periodic modulation of refractive index present. When a light is launched into a fiber, a small narrow band of light will get reflected, which is known as Bragg wavelength. For the detection of ultrasound, an intensity-based modulation scheme is used. This is the schematic of interrogation system in which a 1530 nanometer laser was precisely controlled with a temperature controller and a current controller. The reflected light of FBG is then channeled through a circulator on a photodetector, and the corresponding results are displayed on a DSO. In the experimental setup, an FBG was placed at the focus and the perpendicular to the ultrasound transducer, as shown in the figure. Ultrasound transducer was first cross-calibrated against the standard needle hydrophone or the excitation range. The transducer that was used in our studies are linear and are able to generate a maximum of 1.2 megapascal of ultrasound pressure. Experiments was then performed, first aligning the FBG sensor with the transducer until we get the maximum signal on the photodetector. The transducer excitation was varied and corresponding photodetector voltage was then recorded. These experiments done at three different frequencies with their respective transducer. Graphs plotted with the photodetector voltage and ultrasound pressure. FBGs offer a high linearity greater than 0.98 and a high sensitivity over the excitation range. Our results shows a good repeatability with a value of coefficient of variation less than 5%. At higher frequencies, linearity is relatively slightly poor due to the nonlinear propagation of ultrasound. In this work, we demonstrated the ability to detect ultrasound using a FBG sensor in biomedical frequency range. Our future work will then focus on the assessment of 3D ultrasound field. We thank to IIT Gandhinagar for funding this project. I also thank to Muse Lab and Photonic Lab members for their valuable suggestions.